So because there's been a lot of struggle and effort to come up with some reasons.
So I am going to start this problem over, and I will try to delete the other video. I don't know if I'll be able to, but I'm going to start this one over. So we're going to draw the normal curve with the mean in the middle, which is 8.6. And you can do your standard deviations if you want to. If not, I'm going to go right here to 8.47 and right here to 8.73. This is my mean line. And what I'm going to have to do is get my z-scores so that I can compare, because we are trying to find what is in between these. So the z-score, oops, you can't even see what I'm doing, sorry. So here's my mean, here's my lower, here's my upper, and we're trying to find out what is in between. So the z-score is our data point minus the mean divided by the standard deviation, and this one comes out to be negative 1.18. Negative 1.18, and the other side is 8.73 minus the mean, and it comes out to be 1.18. So when I look these two numbers up on my table, I find this to be 1190 and this to be 0.8870. So to find my probability, what I want to do is subtract my areas, and I find that the probability that the mean is between 8.47 and 8.73. I believe that's the probability of the mean weight of a randomly selected candy bar would be 0.762. Okay. Now, the next problem, this comes from section 8.1. Took me forever to find this one. Now I'm going to forget how to do it. So we are looking, we have a mean of 37 chips, and we are looking to find the probability that the mean number of chips is greater than 38.7. And so what we're going to have to do is find the random variable 52. So first we're going to use the formula for the z-score. We have to take the sample size into play, and so we use the z-score that says the data point minus the mean divided by the standard deviation divided by the square root of the sample size. And so we are going to say 38.7 minus 37 divided by the standard deviation 2.3 divided by the square root of 52. So three, 1, 8, and so 1.7 divided by 319.319 Okay, I had to pause because I was coming up with a crazy number for my z-score and had to figure out what was going on. The only thing I could figure out is this number, my sample was too high. So I changed my sample to 12 and I will kind of start the problem. Represent, graphically label, and shade the graph appropriately. So we're talking about a mean of 37 chocolate chips and a standard deviation of 2.3. So we could do our standard deviations out, but that's not necessarily because we can't use the empirical rule. If 12 cookies are randomly selected, find the probability that the mean number of chips is equal to, but I have shown is greater than. So we'll do is greater than 38.7. So here's the mean number of chips that is greater than 38.7. So what I'm going to want to use is this formula, which is, you probably can't read that, so let me write it over, which is the z-score, which is x minus the mean, divided by the standard deviation, which is divided by the sample size. So we've got 38.7 minus 37 divided by the standard deviation, which is 2.3, divided by the square root of 12. And that gives us 2.56. Remember, you have to put this in parentheses before you divide that. And that's a z-score, so we look that up on our z-chart. 2.56, which is 0.9948. But that would be this side, 0.9948. So to find what's greater than, we would say 1 minus 0.9948. And so the probability that the mean number of chips is greater than 38.7 would be 0.0052. There's a couple more problems, so I will pause this video, or I'll stop this video and start the next.